Okay guys, this video is going to talk about two things, scatter plots and regression models. So basically like a scatter plot is kind of these four things that you see here, right? You've got a graph that measures two variables. So in this first example, it compares height of somebody versus age, right? So how tall is somebody versus how old they are. And then what you have is you have a bunch of points. So in this first example, if I zoom in and zoom in, you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 data points. So basically they found the height and the age of 17 different people and they plotted them on this graph. We're actually going to talk about the regression stuff first. And regression models will help us understand how closely things are correlated. So correlation measures if two variables are related. For each of these four graphs, we're going to determine whether the two variables are correlated. Is there a connection between the two items? So if we look at this first graph here, and I look at those 17 points, there is a little bit of a connection, right? As the age increases, right, as people get older, their height is also increasing. I'm just going to write that as a sentence. As age increases, height also increases. And this can be seen when you look at the trend. Like if I were to look at these points, and even if I were to like kind of block them off, in this section, you can kind of see that there is an increase. So I would say, yes, there is a correlation between these things. And the correlation is as age increases, height also increases. Therefore, they are, and we'll summarize this after, but this is positively, I'm going to say they have a positive correlation. Right? There is a connection there. What about graph B? The area of something versus the length of the shape. Well, if I look at this, as the length increases, the area is also getting bigger, right? So these points, as length gets bigger, the area is also increasing. So as length increases, area also increases. So that means there is a correlation. Therefore, the two variables have a positive correlation. And we will talk about that in a minute, but positive, as one goes up, another one goes up. A positive and a positive change, positive and positives make a positive. What's different between these two sketches? So A and B, we said they both have a positive correlation, but if I were to look at the trend in those data, or in those data points, the first one is more linear than the second one, meaning it's kind of like if I were to draw a line, let me change colors, like it's kind of following that linear trend. Whereas for area, it kind of does like a curved trend. We're going to focus today on those linear trends, but it doesn't always have to be a linear correlation. Okay. Let's look at C. Is there a correlation between the temperature and the precipitation? How much rain or snow there gets? It doesn't really look like there is any correlation. This point here is a very low temperature and high precipitation. this point here, high temperature and high precipitation. Down here, low temperature, low precipitation, high temperature, high precipitation. So there is no trend or no correlation. Right? Trend is another word that you can use. Right. So that means, so no correlation or trend between the temperature and precipitation. Last graph, last scatter plot, is comparing price and sales. So how much something costs compared to how many items they sell. Well, what do you notice as the price increases? Right, so very low price up here, they're selling a lot of items. As they increase the price, the number of items they're selling are going down. Right? Increase, and look at how low the price is over here. So that scatter plot is saying as the price increases, the sales decrease. That's an opposite connection, right? As one goes up, the other one goes down. Therefore, price and sales have a negative correlation. Negative because it's opposite signs. I'm going to zoom out and I'm just going to talk about a few things. Maybe feel free to add some kind of points. So here, in the first two, I already drew like a line or a curve that represents the data. For the sales, maybe you could say it does this, right? Or maybe it does that. But this is what we're going to talk about now. So today's lesson, it's focusing all on scatter plots. And with scatter plots, we can do a couple things. We can say like, how correlated are those items, right? Are they really correlated, somewhat correlated, not correlated at all? Is it a positive? Is it a negative correlation? And then we can also put in lines of best fit or curves of best fit, but today it's going to be just lines. So in your notes here, there's a few blanks to put in. It says the correlation coefficient. So the correlation coefficient is always represented by the letter R. Okay, kind of think of like, what's the relationship between the two? It measures the strength and the direction of a linear relationship seen in a scatter plot. Okay, so like, how close is that relationship? And we'll talk more about that. R, the correlation coefficient, always has a value between -1 and +1. And I'm just going to pause there. If we look at a number line here, and it goes from -1 to 1. 1 is a very strong positive correlation. You might want to add this to your notes. -1 is also a very strong correlation, but it's a negative correlation. I'm going to zoom in here. I want you to add this to your notes. What does a strong positive correlation look like? Well, positive means as one goes up, the other goes up. Or think about what we've done with linear stuff. Positive means the line's increasing. So a strong positive correlation would mean, oh, those points are like perfectly lined up. Similarly, a strong negative correlation means those points are almost lined up, but a negative line goes down. So those are the two extremes. It's perfectly negative or it's perfectly positive. Strong negative, strong positive. In the middle, we have 0. 0 means no correlation. No correlation means there is no trend in the data. You just have points all over the place. The number range then from 0 to 1 or 0 to -1 just relates to like how close they are, right? Because there's not those two extremes. It's not no correlation or they all line up. You might have something between 0 and 1. So it has a positive trend. That's like that, right? Those points are not perfectly lined up, but it's not no correlation. There is a trend that it's increasing. Something like that might have like a moderate R value, something like 0.6 maybe. Maybe because it's in the middle, I'll say 0.5. Similarly over here, -0.5 would be the same idea. Negative, so the trend goes down, the correlation is a negative correlation, but they're just not perfectly lined up. So maybe something like that. It's decreasing, but those points don't all line up. Basically, the further the points are apart, the lower the closer you are to 0. Okay. Let's just finish filling in this. Nope. Graphs with a blank correlation are. Graphs with a negative correlation are decreasing. All right, that's stuff we talked about in linear. And then graphs with a positive correlation are increasing. I'm going to just pause and I'm going to kind of show 3 different positive correlations, and just so you can see the difference in R values. You don't need to write this to in your notes. I'm going to draw 3 scatter plots, all with a positive correlation coefficient. Positive, and they all line up perfectly. That's 1. Okay, this is like perfectly positive, right? All of those points are on the same straight line. Something that has an R value of 0.8. We say that's a strong correlation. Oops, correlation. And it's a positive, so a strong positive correlation. These points might be just a little bit spaced out, but the trend is they're still increasing. Something that has an R value of 0.5, a correlation coefficient of 0.5, this has a moderate positive correlation. And these are going to be more spaced out than the 0.8. So there is an increase in those points, but you see how far apart those points are? the further the points are from that kind of line of best fit, that orange thing, the smaller the value, the closer it gets to 0. Okay. So let's go through this question. Match each graph with the correlation. So which of those graphs could have an R value that is negative 0.76? Negative means the trend is decreasing. Strong means they're somewhat close together. They're not lined up, but they're not really far apart. If you look at A, B, and C, B is the only one with a negative correlation. So I would say B matches that R equals negative 0.76. .013 versus 0.49. 0.13 is a very weak correlation, like it's close to 0. 0.49 is moderate, so around 0.5. Is A or C the moderate or the very weak one? Very weak would imply the points are very far apart. Moderate, they're a bit closer than very weak. If you look at C, those points are very spread out. You might almost say there's no correlation, like it's a very, very weak correlation. There's not a trend that you can see in those points. Whereas for A, you can see, oh yeah, there is a trend. The points are further off though, so it's maybe just a moderate. Let's estimate some values. So you won't need to actually calculate an R value, and that's something you might do if you take data management. But if we were just to estimate, and if I look at these three things, the middle one looks almost like they're perfectly lined up. So that's going to have the biggest R value. You might even say that R value is 1. If you look at the third graph down here, they're close, but they're not perfectly lined up like they are in the middle. So it'll be something close to 1, but not 1. Maybe you guess 0.9, 0.95, 0.8. That would be fine. This first one, well, I don't know. This one is a pretty weak correlation. So this would be something close to 0. Maybe you notice a slight decrease. Like over time there's a decrease, so maybe like negative 0.2. And again, you won't need to actually calculate these. You'll just need to be able to interpret what do they mean. Okay. So that's the first concept. Okay, regression, correlation coefficient, the R value. The second one, and this is going to be a lot quicker in the video, is what's called the line of best fit. Okay. A line of best fit is a line that most accurately represents a relationship, and it's called the line of best fit. I guess I read that sentence silly. So I'm going to read it again. The line that most accurately represents the relationship is called a line of best fit. A line of best fit has about half the points above the line and about half of the points below it. It will also ignore outliers. So what is an outlier? If you look at graph A below and just like you have a point down here, that doesn't really follow the other trends, so we're just going to ignore that. Some of the points may be on the line, but they don't have to. That's an important one. They don't have to be on the line. So you're not trying necessarily to connect all the points, okay, or trying to connect as many points as possible even. You're trying to get about half above and half below, and that you're going to show the trend of the linear relationship. Okay. And that's just the trend is basically an upward or downward pattern in a data set. So one question here. Which line makes the better line of best fit? The red or the blue line? If I'm looking at this first one, I'm going to say the red line. Because if you look at the blue line, it has 1 point above, 1, 2, 3, 4, 5 points below. So it doesn't match the half the points above, half the points below. B. Here, I would also say the red line. Right? It shows the trend. Actually, maybe I'll say blue. I'm just kind of wondering, is that an outlier? If that's an outlier, I would pick blue, because it kind of represents the trend of that data. If I kind of highlight it, kind of highlights that trend. It goes in that same trajectory. If I include that blue point, then maybe red could highlight it a bit more. That one I could say, like, you could debate that one. Okay, and again, it depends if we're going to include that as an outlier. C, hopefully it's obvious which one is better. The blue one, right? The trend of that data goes down. So you want a line that goes down pretty significantly. That red line's almost flat, and that's not what the points do. And then for D, I'm going to go with the red line. I've got 1, 2, 3, 4 points below, 1, 2, 3, 4 above. Let me check the blue line actually, before I get too confident. 1, 2, 3 below, 1, 2, 3, 4, 5 above. Yeah, so I'd probably pick the red line there again. So draw a line of best fit. When you're drawing the line of best fit by hand, it's not going to be perfect. You just want something that approximates it. So maybe something like that. 2 points slightly above, 2 points slightly below. For this one here, maybe something like that. I have 3 points just above, 2 points just below. That's a close line of best fit. And then this last one, maybe something close to that. You guys are going to work on the Desmos activity now. And when you do the line of best fit, when you get to there, you're going to have to type in these equations, mx plus b. It'll tell you go to the slide before, because it's going to tell you what the m number is. You'll incorporate that into your equation. And it's going to tell you what this number is. I think it's called c as a constant. But you'll just need to remember that. So help each other out. And if you have a lot of questions, maybe ask the teacher to contact Miss Borth and she can help. Okay, thanks.